am here today to talk to you about my journey of teaching reuse. But before doing so, I thought that I would tell you a little bit about my rather schizophrenic educational background. So I got my undergrad from structural engineering, and then I went ahead and had a master's in archaeometry and heritage sciences, which then led me to a PhD in built heritage conservation. And so with a strong emphasis on heritage structures, I have been working on existing buildings and existing infrastructure throughout my whole career. And so when I was offered the faculty position at UCL in 2017, I really started to reflect that background in my teaching, where I really challenged the students in terms of, what sustainability is, and tried to pitch it as a systems problem as much as possible. And I really started to pose the question, what is even more sustainable than a sustainably designed and constructed building? So to build or not to build, that was the question. And, how reuse really sits in the, quite highly within the hierarchy of sustainable design has been a very major part of my teaching. In 2020, I was asked to contribute to the integrated design course in my department for a course that is joint between Bartlett School of Architecture, my department, the Department of Civil, Environmental and Geomatic Engineering, and the Institute for Environmental Design, Environmental Engineering and Design. And so this is quite a particular course where each unit is tutored by at least 3 people representing architectural, structural, and environmental design domains. And we really try to induce in students that sort of understanding of interrelations between all these different domains. So when I was posed the question, I reflected on it for a second and I said, yes, but I want to focus on reuse. And this, of course, was done before, but it wasn't a well-established part of the integrated design course up to that point. And I'm quite pleased that since 2020, our unit has been focusing on that in a rather specialized fashion, and has been a major success. My interaction with students as part of this course has shown me a number of gaps in the curriculum and how we approach to reuse engineering teaching. First of all, the students do not have any holistic skills for assessing existing structures. They are rather unfamiliar with reuse standards and procurements. They have difficulties in interpreting building morphology, no exposure to residual capacity analysis, and no knowledge of repair and diagnostics. So, to be able to address all these problems, it was obvious to me that we need a structured pathway to reuse literacy and hands-on intervention design. And so with all this thinking, I started to develop a module that is focused on adaptive reuse, in its entirety in 2020. Of course, it takes a very long time until you can actually get all the approvals and launch the module, which happened in 2022. So from then on, I have 4 hours a week with lectures, seminars, writing sessions and problem classes, field trips and project work, which I'm going to talk a little bit more about in a minute. But what I want to highlight here is that this module is currently offered to the EMANGE course that I just mentioned, the Engineering and Architectural Design course, but also a number of different, graduate level courses within my department, CEGE. And then also to students of the Institute for Sustainable Heritage, making the cohort that I'm teaching this module a very interdisciplinary, very mixed. So the students do not only learn from me and from the guest lecturers, but also from each other. So it's been quite an interesting cohort and experience. And it is going to be a core module from September 2026 onwards of the new MSc that we're launching in Sustainable Structural Engineering. The module has 2 points of assessment. The first one is an essay where the students are encouraged to come up with a critical appraisal of an existing adaptive reuse project, or go ahead and do some reading on subjects that are complementary to our built environment professions, but the students are traditionally given very little time and space to reflect upon, such as, for example, the social implications of an urban regeneration project and so on and so forth. So that's an individual bit of work with 40%, and then we have a group project that I'm going to tell you a little bit more in a minute. So what do I teach? I teach with the help of my teaching assistant, Kakcan. So what do I teach? I first of all start with an introduction. I make a case for adaptive reuse, and it all starts with the building life cycle, trying to basically tell the students about how the shift from the operational carbon and energy has been shifting to the embodied carbon and energy. And then now we are trying to basically look into this in a more holistic fashion. I tell them a little bit about the activism front and, the rules and regulations changing around these things, not only in the UK, but also in the wider geographic context. I tell them about the existing building typologies and tapping onto my background a little bit on history and theory of conservation. This I deem very, very important because knowing typologies really helps students make informed assumptions when they are dealing with an existing building. And now we talk quite extensively about building diagnostics. We talk about diagnostic stages, different tiers of information, how we really do some detective work to really put everything together and join the dots. We talk about the diagnostic techniques. We launch a lot of demos and in the classroom environment of ultrasonic pulse velocity, flat jacks, mortar penetrometers, and so on and so forth. And I also basically tell them about how we understand the building. It's very important that we understand how the building is put together and the mapping of deterioration. We talk about these things. But we also talk about forensic engineering. I mean, there is a very well-established literature of lots of cases of unforeseen failures, performance issues, or causes of damage that require investigation to determine the root causes. So we talk about these things. It's often, a bit of the course that is taken very well by the students because it's good fun. But also as part of the forensic engineering discussion, I, of course, bring a lot of material from my own experience of working in the field following disasters. So as Elizabeth kindly said, I am the chair of EEFIT, but, for the past 5 years, I am, also as a member of the management committee, very much engaged with the earthquake engineering field investigation team. This is the EEFIT is a part of a specialized group that operates under IStructE since 1980s. And thus far has completed more than 60 post-disaster reconnaissance work following major earthquakes and tsunamis in certain instances to carry out detailed technical evaluation of the performance of structures and other civil engineering works. So as you can imagine, this is a very big source of information for us that has, helped so much the UK to keep abreast with the advances in the earthquake engineering and teaching. So under normal circumstances, when we go to the field, you are seeing here me with a team member following the 2023 Turkey earthquakes. You find yourself in this environment where there are a number of buildings that failed, and there are a number of buildings that are, already, that are standing despite the event. So it's a great, test bed to really, think about, the determinants of structural resiliency in the case of a disaster. So as part of my work on the ground, we, of course, one of the things that we do is the damage assessment. And it's quite interesting to look into that because there are so many different buildings with different load-bearing systems and typologies. And really to pass judgments in terms of the safety of that building, the residual load-bearing capacity is a very interesting exercise, which I carry into the classroom, especially with those structural typologies that the students have less familiarity with, like the vernacular and traditional buildings that you're seeing here. It becomes a very interesting discussion within the class as to the safety levels and repairability of these buildings. And then, of course, the discussion then is diluted to, okay, the age of the building is very, very, so this is an old building, so it's normal that it falls down, perhaps. It's, of course, a nuanced sort of discussion, but, often it comes down to that, with the discussions with the students. But then, of course, we are seeing lots of new builds as well that are damaged. And then we start discussing all of these new builds that didn't stand the test of the earthquakes. But the disaster, post-disaster reconnaissance content that I'm bringing to the classroom is also helping the students develop an understanding of the waste implications of a disaster. And how it's very important that the engineers really are able to differentiate the building stock, the portion of the building stock that can continue to their service lives after a disaster, and those that should be taken down and rebuilt, becomes very, very important and established in their minds. Other content that we are covering in the module is, of course, the intervention design, from very, very simple repair methods like mortuary, repointing, or kuchi, sort of methods, all the way to more advanced techniques of strengthening. We just cover them. Removal of existing elements, addition of new elements, regulatory framework to some extent, buildability and site constraints, foundation assessment, construction sequence, vertical extensions. And despite the fact that there's a very strong emphasis on structural engineering in my module, I also tap onto a little bit the energy retrofit and hydrothermal performance assessments and so on and so forth. We bring a lot of case studies to the classroom, also with the help of my industry sort of guest lectures, and that also helps them to really see the real life implementation of these techniques. And we also do have a field trip that we organize every year with the help of the Architecture Association. Okay, now I'd like to tell you a little bit about the group project. This group project I have been running with the support of ARUP. Steve Fernandez, Stuart McNash, and Will James. I'm very grateful for their help. They bring these group projects into our classroom. Often we are working with the projects that they are working on at that given time. We have been working on Castle Meadow campus for the past couple of years, for example. This is a grade 2 listed site that has been originally put together as a HMRC campus, but then recently purchased by the University of Nottingham. And the project was all about transforming it into a modern university campus. And in parallel, the ARUP teams were working on this team. My students also in the classroom were doing the same. Well, so the ARUP team came to the class and told my students about the structural engineering considerations of the site, of this particular case, but also building services and sustainability related considerations. And they work on this around 7 weeks, and all the data, drawings, and all the sort of additional information that should underpin the student analysis are brought in by the ARUP team as well. The group projects are then assessed by a multidisciplinary panel, where also the industry again features quite intensely. So here are some of the outputs that we are seeing here. I'm not going to have the time to go in depth with these things, but the students are expected to bring the design intent. They need to be able to articulate that, the drivers and constraints of design. They need to come up with a program and the justification of that, the site analysis, building assessments. An iterative design process is expected to be demonstrated, the massing, plan layout, material and structural system iterations, and then to demonstrate the viability of their chosen scheme and the resolution of design. Because of the quite interdisciplinary nature of my student cohort, sometimes specialized content is brought in depending on the constitution of the group. For example, the acoustics, the HVAC systems, daylight, etc. So from all this, my key learnings, just as a summary, we need to embrace reuse, not as a design choice, but as a resilient strategy. And engineering education must evolve. Students need structured exposure to existing buildings from early on, not quite late, within their engineering or otherwise built environment education. Typologies and diagnostics content is foundational, because that's not only really help them to better understand an existing building, but also really supports their approach to new design. Real world complexity is a teaching asset. And, I am very lucky to be able to sort of bring content that EEFIT is producing, but there is also a lot of literature around, again, like unexpected failures, post-disaster performance of buildings, etc., which I find a very good and natural supporting element to the reuse teaching. And lastly, I would like to say that I have benefited massively from my partnership with the industry, because they really can bring that sort of real life elements and the actual industry on-site challenges to the classroom, which really supports student teaching massively. Thank you very much.